Hello, Math 95 students. We are looking at a review of our class. Basically, this is going to go through several of the concepts that we learned throughout the class this quarter. This is going to help you prepare for the online standardized assessment for Math 95. I would recommend that you would try this assessment practice assignment first before you watch this video. Do what you can on your own, and then come back to watch the video to do the things, to look at the things that you struggled with. I think it'll help you the most to do it that way. That being said, let's go on with number one. Number one is simplifying a square root. So if we're simplifying the square root of 40, all right, a couple of ways we can do that. One is to get it down to its prime factors. So maybe we start out with 4 and 10. You could start out with 5 and 8. You could start out with 2 and 20. It doesn't really matter how you start, because we're going to end up in the same place anyway. 4 breaks down to 2 and 2. 10 breaks down to 2 and 5. And remember, a square root, there's an understood index of 2 here when there's no index written, which means we're looking for 2 of a kind. And so we have 2 2's that we can take out as a 2. But that 2 doesn't have a partner, and that 5 doesn't have a partner. So they have to stay underneath the root. So this pair of 2's comes out, and it's just a 2 when it comes out. That 2 and that 5 stay underneath, and since they're staying underneath together, they come back together to make 10. So 2 root 10 would be the answer to number one. All right, number two. Number two is a lot easier than it looks, because this is already in factored form. It's already factored for you. All you have to do is set both of these factors equal to 0. So if we set x minus 8 equal to 0 and x plus 11 equal to 0, we solve them both, and we just get x equals 8, and we get x equals negative 11. So 8 and negative 11 would be our answers there. And you can see that that's pretty much just the opposite of what those numbers are in the factors there. Number three, we're told to multiply this and simplify. So 2 square root 5 times square root 10. Since the 5 and the 10 are both under a square root, when you multiply them together, the 5 and the 10 can multiply together under a single square root. So 2 is still on the outside, and under the root we have 50. Because 5 times 10 gives you 50 on the inside of that radical. Now the square root of 50 can break down to 5 times 10. And then the 10 can break down to 5 times 2. And so we're looking for 2 of a kind, and we have 2 5s with an extra 2 left over. So the fact that we have these 2 5s means that I can bring a 5 outside of the radical. And so when the 5 comes outside of the radical, there's a 2 already out there. So the 2 and the 5 combine to make 10, because 2 times 5 is 10. And that extra 2 is left underneath the radical. So that's the answer. All right, number four. The way that I taught you to do this is to get everything off the bottom. So that's what I would recommend you doing. I would recommend you getting everything off the bottom. So the first thing I might could get off the bottom is that 3x. And the way that I'll do that, since the 3x is on the bottom, it's being divided, I'll do the opposite to get it off the bottom, which means I will multiply it. But if I do it to one term, I have to do it to all the terms. So I got to do the 1 times 3x and the 3 over 2x times 3x as well. And so what happens is this 3x and that 3x cancel each other out. And so that just leaves me with 5. Here, the 1 multiplies with the 3x and you get 3x. Here, there's something that cancels. Not the whole thing, but at least the x's cancel, right? That x and that x can cancel each other out. But the 3 and the 2 don't cancel each other out. So then I have to multiply. That 3 gets multiplied with this 3 to get 9. And I still have that 2 on the bottom. So now, the easiest thing might be to just multiply everything by 2 to get that 2 off the bottom. So I multiply this by 2 to get that 2 off the bottom. Multiply this by 2. Multiply this by 2 as well. So that cancels that out. So that leaves me with 5 times 2 is 10. minus 6x, because 3x times 2 is 6x equals, and over here I've just got 9. Now this doesn't look like a hard problem at all. We're just going to get x by itself from here. So I would subtract 10 from both sides. I'm trying to get x by itself. That gives me negative 6x equals negative 1, because 9 minus 10 is negative 1. Then I divide both sides by negative 6. And that gives me x equals negative 1 over negative 6 is just a positive 1/6. And that's it. That's the answer. All right, number 5, it says to factor this. But before we factor this, we need to combine those like terms in the middle. So I would go ahead and combine those, and I would get x squared plus 7x plus 12. And now I can factor it. Remember how to factor a trinomial? These two things have to multiply to get the x squared, so that's x and x. These two things have to multiply to get 12 and add to get 7. So that's going to be positive 4 and positive 3. And that's it. It's factored. All right, on number 6, I have x plus 4 over x minus 3 equals x minus 6 over x plus 1. And the way that we approach these rational equations is just to get these things off the bottom. So I want to get the x minus 3 off the bottom, then I multiply by x minus 3. And then I have to do the same thing to this over here as well. So the x minus 3's cancel here. That leaves me with just x plus 4 on the left side. On the right side, it doesn't cancel, so I have to distribute the x minus 6 with the x minus 3. And so when I distribute that, it gives me x squared minus 3x minus 6x plus 18. All right, plus 18, if I can fit that in there. And then the minus 3x and the minus 6x are like terms. So when I write that, it's going to be x squared minus 9x plus 18. And it's still over x plus 1. So now what I would do is I would try to get the x plus 1 off the bottom. And I would do that by multiplying by x plus 1. And I have to do the same thing over here. So I'm going to take that whole expression on the left side and also multiply it by x plus 1. So the x plus 1's cancel over here. So what does that give me? Here I have to distribute. That's going to be x squared plus 4x plus 1x plus 4. Like terms there. So that gives me x squared plus 5x plus 4 equals x squared minus 9x plus 18. Now it's just a matter of what just happened there. Now it's just a matter of what happened. It's not what I wanted to happen. Okay, let's just write it over again. Plus 18. Now it's just a matter of getting the like terms together, combining all your like terms, and seeing what you can do to solve it from there. So I think what I'll do is I will move this x squared over here with this x squared by subtracting x squared from both sides. At the same time that I do that, I'm also going to go ahead and add the 9x to both sides. And at the same time, I'm also going to go ahead and subtract 18 from both sides. That combines all my like terms kind of in one step. So that the x squared minus x squared actually cancels out. So that's gone. 5x plus 9x gives me 14x. 4 minus 18 gives me minus 14 equals 0 on the right side. Now get x by itself simply by adding 14 to both sides. And you get 14x equals 14. Then divide by 14 to get rid of that right there. And we get x by itself. And x equals 1 is the answer. All right, number 7. I'm factoring that expression. So 3x squared plus 2x. Ooh, that was ugly. Plus 2x minus 8. What you should do, maybe you can remember how to do this already, but I would look for a GCF first anytime I'm factoring, but there's no GCF. So this is a trinomial, and I have a number in front of the x squared. That means I use the AC method, also known as the slip, slide, slip method, which means I take that number in front of the x squared, and multiply it down there with that last number. And rewrite it as x squared plus 2x minus 24. And then I factor it like I have already done before. X and x, and what multiplies to get negative 24 and adds to get 2. That'd be a positive 6 and a negative 4. So I slip the 3 down there with a negative 8, but then I have to slide the 3 back up under these two numbers. That's kind of uncheating. It's undoing what we did before when we changed the problem. And so now you reduce, if it'll reduce, like the 6 over 3 will reduce. So that becomes x plus 2. All right, if it won't reduce and you have a number on the bottom, then you slip that number back in front of the x. So slip, slide, slip. So that gives me 3x minus 4. And that is it. That's the answer. Okay, number 8. The way that I would do number 8 is I would go ahead and do the square root method. So I'm just going to get x by itself by taking the square root of both sides. So x plus 5 squared equals 16. I will get rid of that squared exponent by taking the square root of both sides. That cancels out. So I'm left with x plus 5 equals. Now remember, when you take the square root of both sides, you got to put plus or minus in front of that result. So the square root of 16 is 4, and we got to put plus or minus 4 there. Then I will subtract 5 from both sides. So that gives me x equals, go ahead and write the negative 5 first. So negative 5 plus or minus 4. And since these are just numbers, we can simplify those down. This can just become negative 5 plus 4 and negative 5 minus 4. Negative 5 plus or minus 4 becomes negative 5 plus 4, negative 5 minus 4. And negative 5 plus 4 is just negative 1, and negative 5 minus 4 is just negative 9. So those are my two answers for x there. All right, number 9 is a lot like number 6. 3 over x plus 4 equals 4 over x minus 1. And I will multiply, I will get rid of the x plus 4, get that off the bottom by multiplying by x plus 4. And I got to do the same thing over here. So that cancels that out. And so that gives me just 3 on the left side. On the right side, I need to distribute that 4 because it doesn't cancel out. So it's 4x plus 16 over x minus 1. Then I will get the x minus 1 off the bottom by multiplying by x minus 1. And I have to do the same thing over here. That cancels out. So that gives me 3x minus 3 when I distribute this over here equals 4x plus 16. Now just get your x's, get your like terms together. So I think I will subtract 4x from both sides. That gives me negative 1x, or just negative x, minus 3 equals 16. Then I will add the 3 to both sides to get the x by itself. That gives me negative x equals 19. Then I will divide both sides by a negative, or by negative 1, to get rid of that negative 1 in front of the x. And so x equals negative 19 is the answer. Now, I do need to remind you that you need to check on these rational equations. You sometimes have to check to see if it works. What I mean by that is, when you plug it back into the original equation, you got to make sure that it doesn't make the denominator become 0. And that it obviously doesn't. Like, you plug 19 in here, the denominators won't become 0. And I should have checked that also on number 4 and number 6. If I remember correctly, the answer to number 6 was 1. And if we plug 1 in, it doesn't make the denominators be 0 either, because 1 plus 1 is just 2. 1 minus 3 is negative 2. So it doesn't make the denominator 0. I believe the answer to number 4 was like 1/6 or something like that. So if you plug that in, it doesn't make the denominator 0 either. So we're good on all those so far. But we do need to remember to check those and make sure that if they do make the denominator become 0 in the original problem, they are not a true solution. It's called an extraneous solution. And so when that's the case, if you don't have any solutions left, then you could say no solution. Or if you have two numbers that are solutions and one of them works and one of them doesn't, then it's just one of the numbers. You leave the other one off for the solution. All right, number 10, the square root of x plus 4 equals 6. I'm going to get x by itself, and the way that I do that is I have to get rid of that square root. How do I get rid of a square root? I use a squared exponent because that's what the opposite of a square root is. And so I have to do the same thing to the other side as well. So that cancels, and it leaves me with just x plus 4 equals, and on the right side, 6 squared is 36. Now it's a simple problem. I subtract 4 from both sides, and the answer is 32. On these radical equations, you also have to check to make sure it doesn't mess up the original problem. So in other words, take your answer and look to see if you plug it in, does it actually work? So the square root of 32 plus 4 equals 6. So that's the square root of 36 equals 6, and that is true. The square root of 36 is 6. So 6 equals 6 is true. So we're good. If it didn't work, then you would have to scratch that solution out, and then we don't have any solutions at that point, so you'd say no solution. Number 11, 3 over x minus 7 over 2 equals 6 over x. Again, I'm just getting the things off the bottom, so I'm just going to multiply everything by x to get rid of that x on the bottom. So that cancels out that x right there, and it also cancels out that x right there. So that gives me 3 minus 7x over 2 equals 6. So the 7 and the x had to multiply. Here, I'm going to multiply everything by 2 so that I can get that 2 off the bottom. So that cancels that out. That gives me 6 minus 7x equals 12. And then I just get x by itself by subtracting 6. So negative 7x equals 12 minus 6 is 6. Then divide by negative 7, and that gives me x equals negative 6/7 as the answer. And we remember to check it. If we plug negative 6/7 in for x in the original problem, it does not make the denominator 0, so it's a good answer. Now you might ask, I'm thinking you might be questioning, well, why do we have to check some of them and not others? Why do we have to check our answer for these radical equations and for these rational equations, but not for these quadratic equations? That's a good question if that's a question that you've asked yourself. It's because for the quadratic equation, there's no value for x that you could plug in that could make that problem strange or make it screw up. For a rational equation, meaning when you've got a fraction, there's one thing that could happen that could make that go crazy, can make it screw up, and that's if you get a 0 on the bottom. Because if you divide by 0, it's undefined. And if you have a radical equation, there's one thing that could happen that could make this go crazy, and that is if you get a negative number under the radical, and that makes it become imaginary, which kind of screws up our real answers as well. But that kind of thing could never happen to a quadratic equation. No matter what you plug in for x, it's always going to be fine. Nothing strange can happen there. So that's why. All right, moving on to number 12. I think we're on number 12, right? So this is a quadratic equation, and I will simply solve it by factoring. So I'm going to factor it. There's no GCF to take out, so I'm just factoring the trinomial. I'm saying what multiplies to get negative 6 and adds to get negative 5. What multiplies to get negative 6 and adds to get negative 5. That would be a negative 6 and a positive 1. And so you solve both of those, and you get x equals positive 6 and negative 1. I can imagine some of you might have, because this is kind of tricky, some of you might have said, well, what about 2 and 3? What if you do a negative 2 and a negative 3 or something like that? But that won't work because negative 2 times negative 3 is positive 6. And if you change the signs around, you're never going to find anything that works to actually get you a -6 when it multiplies and get you a -5 when it adds. So the 2 and the 3 just won't work, but the -6 and the 1 will, because -6 times 1 is -6, and -6 plus 1 is -5. All right, number 13. Plus 2 over x plus 2. All right. Again, a rational equation where we want to get everything off the bottom. But before we start to do that, if you have anything on the bottom that can factor, go ahead and factor it. Like the x squared minus 4, that factors. That's the difference of squares. It factors as x plus 2, x minus 2. So I'm going to go ahead and replace that x squared minus 4 with what I just said. X plus 2 and x minus 2. And now I want to get things off the bottom. What do I want to get off the bottom? Well, let's just take it one thing at a time. Let's get the x plus 2 off the bottom first by multiplying everything by x plus 2. So that cancels that out, and it also cancels that out, but it doesn't cancel out over here. So what does that give me? On the next line, it gives me 5 over x minus 2 plus 2 equals, I have to distribute here, 4x plus 8 over x minus 2. Now let's get the x minus 2 off the bottom by multiplying everything by x minus 2. So it cancels out there, and it cancels out there. And so what do I have? I have 5. This will distribute, so plus 2x minus 4 equals 4x plus 8. Now just combine all your like terms, get your like terms together, combine them, and get the x by itself. So that 5 and that minus 4 can combine. It gives me 2x plus 1 equals 4x plus 8. And I think I'll move my 4x over. I'm kind of out of room here, but let's see. Maybe I can finish it here. That gives me negative 2x plus 1 equals 8. And now I'll subtract 1 from both sides. That gives me negative 2x equals 8 minus 1 is 7. Divide by negative 2, and x equals negative 7 halves. I believe that's the answer. Negative 7 halves. So we look back and we say negative 7 halves will not make the denominator be 0, so it's fine. But if we'd have gotten like a 2, 2 minus 2 would give me 0 on the bottom, so we would have had to say that's not a real solution, not a true solution. Or if we've got negative 2 plus 2 would have gotten me a 0 on the bottom as well. But the answer that we got is totally fine. It will work just fine. All right, number 14 here. 2x squared minus 10x minus 28 equals 0. All right, when you factor, we're going to solve this by factoring. Always look for a what first? Look for a GCF first. And then there is a GCF on this problem. What can I factor out from each of these already? I can factor out a 2. And what does that leave me with? It leaves me with x squared minus 5x minus 14. And so the 2 comes down, and then I factor this as what? What will multiply to get negative 14 and add to get negative 5. That would be a negative 7 and a positive 2. So now I will just set each of these to 0. 2 equals 0. That doesn't give me a solution there. There's no x to solve for. Set x minus 7 equals 0. Set x plus 2 equals 0. And I get x equals positive 7 and negative 2. And I believe we've made it to the last one. Number 15. 2x squared minus 10x plus 3. So you might say, well, is there a GCF? Nope, there's not a GCF. Then I need to try the AC method. So x squared minus 10x plus 6 if I do the AC method. And then you say, well, can I factor that? You say, can anything multiply to get 6 and add to get -10? Nope, there's nothing that can do that. So it won't factor. So what do you do with a quadratic equation like this when it won't factor? You got to do that quadratic formula. -b, -b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So -10 plus or minus the square root of -10 squared minus 4 times 2 times 3 all over 2 times 2. So let's clean it up. That's 10 plus or minus the square root of 100 minus 24 over 4. So that's going to be 10 plus or minus the square root of 76 over 4. Now I got to see if 76 will break down. So let me see, 76. That's going to be 2 times 38, which is 2 times 19. So I've got a pair of 2's, but an extra 19 left over. So then that becomes 10 plus or minus 2 square root 19 over 4. And then it will reduce because the 10, the 2, and the 4 will all divide by 2. So that becomes 5 plus or minus square root 19 over 2. And that's my answer. And that does it for this assessment practice. Good luck on that, and good luck on that standardized assessment. Hope you make good on it. I'll see you again in another video.